Wishing you all good health and happiness. God bless you.
This message is brought to you by Ministry of Health, Buganda Kingdom, UNICEF, and World Health Organization.
Official takes the crown, Favabose with the best in town. Official new chapter, anti-new chapter. Mbadde bulijjo ndobedde ku quantity labate official omwana bweyiwawo quality. Empa much more data for less, nempona stress wali ate ku face. Unbeatable data bundle with official internet I can handle. Yes, official made it for you. The best and most affordable bundles are finally out. Dial *133# to select and activate your best data bundle, because with official you're very special.
Official, connecting communities. Africell is regulated by Uganda Communications Commission.
Somera mu ddiiro lyo ng'ewagiddwa Maryland High School erisangibwa Entebbe. Ssomero ly'abawala n'abalenzi tusomesa arts ne sciences okuviira ddala ku siniya esooka okutuukira ddala ku siniya ey'omukaaga nga lisangibwa mu kifo ekiweweevu obulungi. Tulina ebisulo eby'omulembe, science laboratory ssaako ne computer lab wamu ne.
She gives you her number, but your pen didn't work and the bus is gone. Get a pen you can rely on. Big Crystal, the long-lasting pen with perfect ink flow.
Wamune.
Green Hill Academy has high standards of learning and the teachers are very good. They give you a sense of belonging.
Green Hill has helped me to discover my talent.
The environment is good.
Encouraged us children to be excellent.
Wamune.
Combo University, a private chartered university that offers world-class education at all levels, including certificates, diplomas, bachelor's and master's degrees. Our courses include computing and IT, law, journalism, nursing, business administration, education, fashion and design, and many more. Admissions for the August 2020 intake are still open. Will you join us?
Wamune.
Kids Kingdom Kindergarten and Daycare. Somero ly'abaana bato. Omuzadde leeta omwana ogenda okola ebibyo. Ebyokuzanyisa by'abaana byonna mu nsi tubirina. Ate nga abaana we bazannyira wagazi nnyo. Jjukira security enka. Amasomero gonna gali mu kikomera. Abasomesa be tulina bakugu mu baana. Abaana tubaliisa bulungi nnyo munnange. Tulina main campus e Buddo Naggalabi nga bwakayisa Buddo Junior.
Tubaniriza mwena abalabi ba Terefayina mwebala okuzuukuka naffe mwasuze mutya ne. Our candidates, good morning. We are yet to start another lesson of organic chemistry. Today's lesson is organic chemistry, and the other time I left you with a simple question. I hope you tried it. Yeah? And before we start, let's first pass through very fast what was expected of you from that question. If you remember, we said is a compound, the compound A, it is compound A was reacted with sulfuric acid to form compound B, this one, and then also this one. This one, remember, we said was reacted with the sulfuric acid to give compound B and this compound. Then that B reacted with the sodium metal. This B reacted with sodium metal with effervescence, but had no effect on litmus paper. So this one reacted with the sodium metal to form bubbles of a colorless gas, but it did not have any effect on litmus paper. So what does that one tell you? It tells you that this compound B, if you can remember, which compounds react with sodium metal? Which organic compounds react with sodium metal? It goes to alcohols. Now, so it means that is a hint to tell you that this substance B which is formed is an alcohol and not an ether. Because if you know, ethers don't react with sodium and they are neutral to litmus paper. However, alcohols react with the sodium metal, although they are also neutral to litmus paper. So that information is essentially tell you that this one is what? Is an alcohol. It is neutral to litmus paper and it reacts with the sodium to produce bubbles of a colorless gas. So the question was to write the isomers of B. Write the names and the structural formula of the isomers of B. We are not on this one, we are on B. So once you know that it is an alcohol, then you can write as many structures of alcohols as possible using 4 carbons, 10 hydrogens, and 1 oxygen. So one of them I would expect you make sure you use 10 hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4 carbons, 1, 2, 3, 4, and 1 oxygen, 1. So that is one of the compounds. It can be that one. But also, it can be this one. It can be that one. But also, it can be this one. Also, it can be this one. See, it is a matter of writing these, arranging. I think those are the ones. Now, of course, there would be other ways of writing a compound which has 4 carbons, 10 hydrogens, and 1 oxygen. But those other compounds would not be alcohols. They would be ethers. And ethers don't react with what? With the sodium. But we said alcohols react with sodium. So it can be any of these. So they asked the names, I think. The name, this one, if you remember this one, 1, 2, 3, 4, it would be butane. Butane 1 all. This one would be butane. Butane 2 all. This one would be 2-methyl. The longest continuous chain is 3 carbons, 2-methyl. Propane 2 all. And then this one would be 2-methyl. Methyl propane 1 all. 2-methyl propane 1 all. Those will be the names of the names of our. Now, they said that B reacted with acidified potassium dichromate. Acidified potassium dichromate to form compound D. To form compound D. That B reacted with acidified potassium dichromate to form compound D, which formed a yellow precipitate with, which formed a yellow precipitate with iodine, with alkaline iodine solution. With alkaline iodine solution. Now, so if it forms a yellow precipitate with an alkaline iodine solution, it means that that compound, it has this group. It has the NO group. If you remember, we talked about that group. It means that compound has that group, or the compound, because when you oxidize this one, you get this. That the compound has this group, either this group or that group. That is the compound which react with alkaline iodine solution to form a yellow precipitate. So, already we covered these things. The question would be, we have skipped some question. The question was to name a reagent that can be used to distinguish these isomers. Which reagent would you use to distinguish these isomers? Now, all of them are alcohols. If you remember, we said which reagent do we use to distinguish alcohols? If you remember, alcohols can be primary, secondary, or tertiary. So which reagent do you remember that we talked about that is used to distinguish from these alcohols? If you remember, we said the one we use for distinguishing would be anhydrous zinc chloride, and concentrated hydrochloric acid. The reagent we are going to use to identify these isomers, to distinguish these isomers, is a solution of anhydrous zinc chloride in concentrated hydrochloric acid. Then you start this one. If you remember, we said this one is a primary alcohol. So this one would, if you treated this one with the anhydrous zinc chloride and concentrated hydrochloric acid, this one would do no observable change at room temperature, because this one is a primary alcohol. No observable change at room temperature. This one, you can see that it is a secondary alcohol. This one is a secondary alcohol. So it would give a cloudy solution between 5 to 10 minutes. A cloudy solution between 5 to 10 minutes. That one would be this one. Then this one is a tertiary alcohol. As you can see, if you remember, we said the tertiary alcohol with this Lucas reagent will form a cloudy solution immediately. This one will form a cloudy solution immediately. That is the tertiary. Then this one it is also a primary alcohol, just like this one. So this one, what would be the observation? It would be no observable change at room temperature. Remember to add the word room temperature. So this one and this one, those ones would give the same observation, because this one is primary, also this one is primary. But this one is secondary. This one would give a cloudy solution between 5 to 10 minutes. This one is tertiary. It will give immediate cloud solution. Now, they said B, this compound, reacted. Remember, this compound is either this one, or this one. We don't know yet which one. Now, they said B reacted with acidified potassium dichromate to form substance D, but D formed a yellow precipitate with an alkaline iodine solution. Now, I have said that the compound which will react with the alkaline iodine solution to form a yellow precipitate would be the one with this group. So, from these isomers, which one do you see that has this group or it has the other group? Obviously, it is not this one. So, this one is off. Obviously, it can't be this one. So, this one is also off. Now, this one you can see it has, it can't be this one. Remember, we said that tertiary alcohols cannot be oxidized. So, it can't be this one. So, it means now we are left with this alcohol. This alcohol, when you oxidize it, when you oxidize this, it gives you this. So they said when this one was reacted with acidified dichromate, then they formed a compound D, and that this D formed a yellow precipitate with alkaline iodine solution. So this one is your D. So they said identify B. First of all, we have identified B is this one. So you write this one. B is this one. Then, identify B, D, and so this one is B. This one is your B now. When you react B, it forms D, this one. This D is the one which gives the yellow precipitate. They also asked us to identify that yellow precipitate. If you remember, we said the yellow precipitate would be this one. This is the yellow solid, this one. That was the yellow solid. So, B, we have identified B. D is this one. Then the yellow solid is this one. And then name one reagent that can be used to identify the functional group in D. The functional group in D. And this functional group is a carbonyl group. This one is a carbonyl group. So, to identify that carbonyl group, we use Brady's reagent. That is the answer, Brady's. And if you are using that Brady's thing, Brady's reagent, use Brady's reagent. And the last one is write the mechanism, write equation and indicate a mechanism for the reaction of B and sulfuric acid. B and sulfuric acid. We have identified B. And this one, B is this. So, now this B, it is concentrated with concentrated sulfuric acid. Then it would give you and please write the mechanism. The mechanism already you have, it is just reproducing from your book. The mechanism is there for this reaction. So B reacting with concentrated sulfuric acid, you get an alkene. And then you can write the mechanism. Now, we are on hydroxy compounds. The other time we completed aliphatic alcohols. Those aliphatic alcohols are the ones which are straight chain alcohols, the ones like this, then like this, those are alcohols, the straight chain alcohols. But in those alcohols, there are also others, the one we call the phenols. The phenols. Now, in these phenols, there are those organic compounds which they are aromatic alcohols. Now, those aromatic alcohols are the ones which are like this. They have a benzene ring like this. This one is an alcohol, although maybe an aromatic alcohol. Now, these compounds which are like this, the OH is attached to the side chain. The OH, the hydroxyl group, is attached to the side chain, to the side chain. Those ones are aromatic alcohols. They react in the same way like the straight chain alcohols. So these ones, they are these ones. They react in the same way. However, in phenols now, we want to see the ones where the OH group is attached directly to the benzene ring, the one which is like this. Where the OH is attached directly to the benzene ring. Those are the ones that fall in the category of phenols. The others are like those straight chain alcohols. And their reactions are similar. So we have like this one, good example. This one is the one we call phenol. This one, or hydroxy benzene. Sometimes it is hydroxy benzene. We have another example of phenols. Now we are looking at those the alcohols where the OH is attached directly to the benzene ring. Then we have also like this. This one is also in that category, naphthalene 1O. So this is the category of phenols now we want to look at, where the OH is attached directly to the benzene ring. Now, we want to look at the physical properties. Although all these ones belong to that group of the phenols, but for us, we are going to mainly to restrict ourselves to the phenol itself. Actually, the first member of this phenol is hydroxybenzene, which is also commonly called the phenol. So we want to restrict ourselves to phenol and look at the reactions of phenol. A solution, you find that phenol, a solution of phenol in water is called a carbolic acid. That is a solution. When you put phenol in water, it dissolves, and that resultant solution is called carbolic acid. And it is a very, very strong antiseptic. It is a strong antiseptic. Antiseptic meaning that it kills bacteria. It is a very good antiseptic, this phenol. And in those olden days, the doctors used when doctors would operate patients and the surgery goes well, but at the end the patients would die they didn't know why patients used to die even after the surgery has gone well. Then they discovered that the wounds during the surgery in the theaters, the wounds would be infected, and also in the wards, the wounds used to be infected. So they started spraying carbolic acid. That is a solution of phenol. They would spray the phenol in operating theaters and those wards. And to their surprise, the death rate was reduced. The death rate was reduced by spraying the mist of phenol in the operating theaters. So it is a very good antiseptic. However, even when you are dealing with it in the lab, make sure that it doesn't come into contact with your skin. It burns the skin. If the liquid or the solid itself comes into contact with your skin, it will burn it. So the scientists now decided to use it to produce another derivative, using it to produce another derivative, which also has antiseptic properties, but is less corrosive. It doesn't corrode the skin as much as phenol itself. One of them is the one they use in Ditto soap. So that antiseptic effect in Ditto soap is due to some of those derivatives of phenol that are put in the soap. Now I want to look at preparation of phenol. Preparation of phenol. You know, the good thing with organic chemistry is that we keep repeating. That's why it makes it very easy. It is like the easiest branch in organic chemistry, because for most of the equations we keep repeating them. And if you also try to keep revising, the thing becomes very easy. So preparation of phenol, number one is from benzene sulfonic acid. Is from benzene sulfonic acid. Why I said it is like this reaction now, those of you who have been following, you know this reaction of how you make benzene sulfonic acid. Now, for you is to know what are the conditions for you to change the benzene to the benzene sulfonic acid. What are the conditions? And you have ever seen those conditions. That's why I'm saying that with organic chemistry, it is good that you keep repeating. So this one, you know that we put here concentrated sulfuric acid, and you heat. Concentrated sulfuric acid, and you heat. Then this one is you heat with sodium hydroxide, solid sodium hydroxide, and you heat at 200. Then it will give you this. It will give you now. Then from this one, remember we want to get the phenol. This one actually is 300. So from here actually you put dilute hydrochloric acid and you get the phenol. So all these reactions are not new. That's why we can go faster, comfortably. Those are the conditions. Then next is from benzene diazonium salt. From benzene diazonium salt. From benzene diazonium salt, benzene diazonium salt like this. Want to get the phenol. From benzene diazonium salt, here we put acidified water. You hydrolyze and you warm. Then you get phenol. Now, when you write this benzene diazonium chloride, you have to be very, very careful, because we can also write it like this, that same one. When you write like this, make sure that here you put the charges. If you don't want to put the charges, then it is better you write it like this. But the moment you write it like this, then you must put the what? You must put the charges like this. So be very careful when you write the benzene diazonium salt. Number 3, from aromatic halides. From aromatic halides. From aromatic halides. From aromatic halides. Even I know that this one you already know. If we have like this aromatic halide, you can convert it to this. Aromatic. What are the conditions? If you are putting sodium aromatic halides to sodium phenoxide, this one you put sodium hydroxide at 350 degrees Celsius and 200 atmospheres. Remember, when you get the sodium phenoxide, then you hydrolyze using dilute acid. So that one you also get the phenol. Now, the fourth one. This one is the one which is a bit challenging. It is a bit confusing. I don't know why, but it is very important that you know it. That is from the human process. They say from the human process. Now, that is from the human process. In this human process, benzene is first alkylated. Benzene is, you first alkylate benzene. I know that you also know this. If we alkylate the benzene so that we form this. Now, what do you put here? Because also this one is not a new reaction. It is not a new reaction. You studied benzene and its reaction. You studied alkylation of benzene, and in particular this reaction. So if you can recall, what are the conditions there? Which conditions do you put? Which conditions do you put, if you remember? This one would be concentrated phosphoric acid. Concentrated, that is the alkylation of benzene at 250 and 30 atmospheres. So when you alkylate benzene, this reaction is called alkylation. When you alkylate benzene, you get 1-methyl ethyl benzene. This one is 1-methyl ethyl benzene. 1-methyl ethyl benzene, and this is the one they call cumin. That's why they call it the cumin process. So sometimes they will ask you, write equations to show how you can prepare phenol from cumin. If you have forgotten the word cumin, then of course now you will not be able to do it. Alternatively, they can say a compound contains 30% carbon, 30% hydrogen. Deduce its molecular formula, then you deduce the molecular formula. Then after getting the molecular formula, you find that the molecular formula of the compound is this one. Then they say, write the equation to show how you can convert that compound to phenol. And that's why now we should remember that I'm going to use the cumin process. So this one actually is the one they call the cumin, 1-methyl ethyl benzene, and you get it by alkylation of benzene. Now, after alkylation of benzene, then air is passed through it. Air is passed through this cumin, and when air is passed through, you form this. You pass air through the cumin, and when you pass air through the cumin, then you will form 1-methyl ethyl benzene hydroperoxide. 1-methyl ethyl, 1-methyl ethyl benzene peroxide. Benzene hydroperoxide. Benzene. Here I write it. 1-methyl ethyl benzene hydroxyperoxide. That is, when you pass air through the cumin, then you form 1-methyl ethyl benzene hydroperoxide. Hydroperoxide. 1-methyl ethyl benzene hydroperoxide. Now, when you pass air through the cumin, then you get 1-methyl ethyl benzene hydroperoxide. Now, that 1-methyl is then decomposed with warm dilute sulfuric acid. This 1-methyl ethyl benzene hydroperoxide now, with the dilute sulfuric acid. With dilute sulfuric acid, then you will get a phenol. So this is 1-methyl ethyl benzene hydroperoxide. So this is the whole process. You alkylate benzene, you form 1-methyl ethyl benzene, which is also called the cumin. Then you pass air. When you pass air through that cumin, and when you pass air, you will form 1-methyl ethyl benzene hydroperoxide. Then that 1-methyl ethyl benzene hydroperoxide is decomposed by warm dilute sulfuric acid. Then you get phenol plus. It is important that you get that process because as you can see, it is a bit long and it takes some marks. It's a bit long and it takes some marks. That is the cumin process. Alkylate benzene, you get 1-methyl ethyl benzene, which is cumin. Then you pass air through the cumin. When you pass air through the cumin, then you get 1-methyl ethyl benzene hydroperoxide. Then you decompose that benzene hydroperoxide with warm dilute sulfuric acid, and then you form phenol. Now let's look at chemical properties. Chemical properties of phenol. Now, as you know, phenol and alcohols, these are the straight chain alcohols. They have the same functional group. Both of them have the OH group. Now, the fact that phenol, or these phenols, there is this group, the OH, then the other alcohols also which are like that. The fact that both of them have the OH group, this one and this one, there are those reactions which are undergone by both phenols and the aliphatic alcohols. But there are also reactions which are undergone by phenol and not undergone by the other alcohols. Or those which are undergone by these straight chain alcohols, but they are not undergone by phenols. So you have to point out those ones now. It is very important in case they asked you compare the reactions of phenol, where it differs. Now, maybe here just in passing, we know these alcohols undergo dehydration. If you heat with concentrated sulfuric acid, these ones can undergo dehydration. Although these ones undergo hydration, phenols do not undergo dehydration. So in other words, these ones can undergo elimination, but these phenols cannot undergo elimination. You'll find these alcohols react with the PCl3. This one does not react. These ones will react with the phosphorus trichloride. Phenol will not react with phosphorus trichloride. And although we can oxidize this one, if we put like acidified potassium dichromate, these alcohols would be oxidized. Phenol will not be oxidized. Now, we want to see why. Why it does not why it does not undergo those reactions. Why? It does not undergo oxidation like other alcohols. It does not react with phosphorus trichloride like other alcohols. It does not undergo elimination reactions like the straight chain alcohols. And it is more acidic than alcohols. Phenol is more acidic than alcohols. And before you understand its reaction, you have first to understand why is it acidic. Why is phenol more acidic than alcohols? Why? So, what makes a compound acidic? First you ask yourself, what makes a compound acidic? Now, once you know that one, then you have to know what makes phenol more acidic than the other alcohols. That's where now we are heading. This one I have to go a bit slowly so that you understand it, because it normally confuses students. An acid is a compound which can release a proton. A compound which can release a proton. Now, how do you gauge the strength? So, how do you gauge the strength? Phenol can, in water, it can maybe dissociate like that. We are comparing it, remember, with other alcohols, like this. If, assuming they also underwent this same reaction. We are dealing with the OH group. Both of them have the same OH group, but we are saying the one in phenol is more acidic than the one in the aliphatic alcohols. An acid is one which can produce a hydrogen ion. When we say that phenol is more acidic than the straight chain alcohols, it means phenol produces more hydrogen ions than the aliphatic alcohols. Or it means that phenol easily produces what? Hydrogen ions. It produces hydrogen ions faster or more easily than these straight chain alcohols. Now, when you look at this equation, you can see that for you to form the hydrogen ions, because acidity is due to the hydrogen ions, you can see that before you form the hydrogen ions, it means you break this bond, even in the alcohols. It means breaking this bond so that you produce hydrogen ions, and also this one. Then it means, since phenol is more acidic than the straight chain alcohols, it means the breaking of the OH bond to form this is easier in phenol than it is in alcohols. That one also means that the OH bond in phenol is weaker than the OH bond in the straight chain alcohols. That's why phenol can easily produce the hydrogen ions. It can easily produce the hydrogen ions. Now, although time is almost up, it is against us, but next time I hope we will try to complete this ionization thing, to know why phenol is more acidic than the oxygen here is attached to the ring directly. The oxygen in the straight chain alcohols is attached to the carbon. Now, it means now that since this one is attached, this oxygen which is attached, these lone pairs can interact and form part of the what? Of the benzene ring. The lone pair of electrons on the oxygen atom can interact and be part of the delocalized electron system of the benzene ring, which cannot happen in the straight chain alcohols because here there are no delocalized electrons. So when such a thing happens, it means there is like a double bond is sort of being created between the carbon here and the oxygen here. If the double bond is being created there, it means now you are weakening the OH bond. That one means weakening the OH bond. So if we look at it in this way, if this one is, the electron is going there, then this one is going there. It means the electrons now are coming towards this side. So that one means this bond is becoming weaker. We are strengthening this carbon-oxygen bond is made stronger, but in so doing, you are weakening this one. When you weaken this one, it becomes easier for the bond to break, and then you produce the what? The hydrogen ions. Whereas in this one, these electrons remain on the oxygen because they cannot interact, because here there are no delocalized electrons, which means the OH bond here is stronger than it is in the other one. That one would mark the end of, actually we are going to start it from there next time. Because I want you to understand this thing very well. Students, from my experience, students are always disturbed by this thing. Why this one is this and the explanation. So I'm sure that I will try next time to go through it slowly so that you understand. The moment you understand why, then the reactions will become very, very, very easy. I thank you for watching, and I thank the management of BBS for this opportunity to give to our students so that even if you are in the lockdown, you don't lose much, you don't lose anything, so that you are still up to date. We want to thank the management of this BBS. Thank you, and keep tuned to BBS, and a nice weekend. Thank you.
somera mu ddiiro lyo ng'ewagiddwa Maryland High School erisangibwa Entebbe. Ssomero ly'abawala n'abalenzi tusomesa arts ne sciences okuviira ddala ku siniya esooka okutuukira ddala ku siniya ey'omukaaga nga lisangibwa mu kifo ekiweweevu obulungi. Tulina ebisuula eby'omulembe, science laboratory ssaako ne computer lab wamu ne.
She gives you her number, but your pen didn't work and the bus is gone. Get a pen you can rely on. Big Crystal, the long-lasting pen with perfect ink flow.
Wamune.
Green Hill Academy has high standards of learning and the teachers are very good. They give you a sense of belonging.
Green Hill has helped me to discover my talent.
The environment is good.
Encouraged us children to be excellent.
Wamune.
Combo University, a private chartered university that offers world-class education at all levels, including certificates, diplomas, bachelor's and master's degrees. Our courses include computing and IT, law, journalism, nursing, business administration, education, fashion and design, and many more. Admissions for the August 2020 intake are still open. Will you join us?
wamune
Kids Kingdom Kindergarten and Daycare somero ly'abaana bato omuzadde leeta omwana ogenda okola ebibyo ebyokuzanyisa by'abaana byonna mu nsi tubirina ate ng'abaana we bazanyira wagazi nnyo jjukira security enka amasomero gonna gali mu kikomera abasomesa be tulina bakugu mu baana abaana tubaliisa bulungi nnyo munnange tulina main campus e Buddo Naggalabi nga bwakayisa Buddo Junior.
Kyakabi ku Airtel fuka nantamegwa mu kitundu kyo odizibwe airtime wa bitundu